Hey everybody, happy Tuesday. Here we go, back to back. So, all right, we're going to start out here with some IXL, just kind of reviewing where I had you guys complete an IXL lesson, but I wanted to go through a few of them together with you real fast because it's going to tie in with what we're talking about today. So, if we take a look at these real fast right here, are these intersecting? If you had to pick an answer, what would you say, yes or no? If you said yes, you are correct. They are intersecting with each other. We need to say yes and then submit. That's right. Good. Are these lines, and this is great right here, that we're using this word right here, are these lines perpendicular? That's the word we're going to be talking about a lot today. All right. If you said no, you are correct. They are parallel. These are lines that are going to be going off in both directions, on, and they will never touch each other. Excellent. Are these lines intersecting? If you said no, you are correct. They are parallel. Wonderful. Are these lines parallel? No, they are not. Excellent. Are these lines perpendicular? Now, this is a good question. We'll leave off on this one. We'll do a few other IXLs here about parallelograms. Um, these are not perpendicular. They are intersecting, but they are not perpendicular because they are not meeting in a specific way. All right. I'm going to say yes just because I want to show the IXL explanation for this. All right. So they say perpendicular lines meet at right angles. They make square corners. If you take a look at these angles that are being created here, in this case, this angle right here and that angle right there, those are obtuse. Okay, those are wide open angles, and then this green angle here matches this green angle as well. Those are acute, right? These are not perpendicular lines at all. Awesome. All right. This question, we talked about this yesterday. We talked about quadrilaterals. If you remember the kid on the little quad runner zooming in and out, quad means four, right? So this is a quadrilateral. It has four sides, but it's asking, is this a parallelogram? And I'm going to read the definition I typed out for you guys yesterday, where it said a parallelogram is a four-sided shape with opposite sides parallel. Okay. So do you see opposite sides that are parallel to each other? Meaning, look at this. Is that line parallel to that line? And is this line parallel to this line? If you said yes, that is correct. Is this one a parallelogram? Okay. If you're saying no, you are correct. This is a quadrilateral. Okay. Quadrilateral. It has one, two, three, four sides. But this side here is opposite to this one. They are not parallel. They are eventually going to meet. Remember, look at those L's in parallel. They are parallel lines. This line here is not parallel. So the answer for this one here is no, it is not a parallelogram. Submit. There we go. Good. Fantastic. All right. How about this one? Quadrilateral, four sides, but does it have opposite sides parallel to each other? No, it does not. And we've reached our limit. Good. So I'm done with that. Excellent. Let's take a look at our slides from yesterday real quick. All right, I just want to go through this real fast. You guys can see it this way. All right, just remembering quadrilaterals are these four-sided shapes. Here's our cool dude on his little motorcycle quad runner right there. Quad meaning four, right? It has, if you take a look back at this one, it has four sides or four edges, right? Four sides, four vertices. Vertices are these points, right? So if you want to think about a vertex, that would be like if you ran into that shape, that's the part that would hurt. That's the corner, right? So when you are walking through your kitchen and you like slam your hip into the corner of the counter and it hurts, you just ran your hip into the vertice of the corner. So think of that the next time that happens. So yeah, parallelogram, we just talked about that. Four-sided figure with opposite sides that are parallel. Trapezoid, we talked about these here real quick, where we have four sides, four angles, and opposite sides are parallel. Trapezoids, non-trapezoids, squares, four equal sides, those sides are parallel to one another on opposite, and they meet each other at four right angles. This is going to be what we're talking about today because they form, when they meet, perpendicular edges right here. These are perpendicular lines. They are making a right angle. We'll get to that in a second. Rectangle here, opposite sides are parallel, 4 equal right angles right here. They are also meeting at perpendicular edges. The perpendicular lines are making those right angles, okay? Here's a sheet here real quick that if you are able to print this off, this is great. If you can't, that is fine as well. Okay, so I just want to go over this and kind of draw on this with you guys. So we talked about parallel lines and those L's and parallels, but I want to talk about perpendicular, right? So let's take a look at this first trapezoid. This I'm going to mark this right here. So I want to say line segment DC. And I want to take a look for where is it meeting another line or line segment and it's making a right angle. Okay, I can see this is labeled for me already by a right angle. So now I'm looking at this right here. Okay, so what can I say? I have line segment DC, I have it labeled like that, and then I have line segment again, DA. DA, right here. They make this angle right here when they meet each other, like this, okay? The sign for perpendicular is kind of drawing a small perpendicular like this. You are showing them, look, they are making that little perpendicular angle just like that right angle, okay? On the other hand, I'm going to change colors here. Now, this is where geometry can get kind of neat, and it can also get a little crazy a little bit because you can look at the same shape so many different ways. If I said, all right, DC, and this is just kind of bringing back what we talked about yesterday, DC is parallel. I'm drawing those little parallel lines there to, I don't want to accidentally draw a happy face because I'm not happy. Right here, line segment DC. Now I'm going to shade this in green here. Which one is it parallel to? Well, it's parallel to AB. Okay, does that make sense? So, but this is review from yesterday. This is today. Okay, so these two lines are forming, these are perpendicular lines to each other because when they come together, yes, they're intersecting, but when they intersect, they're making a right angle. That's special. Okay, that's what's so special about them. All right, now if we look down at this one, I used this one yesterday when we were talking about parallel lines, but do you see any perpendicular lines here? Dora moment. Go ahead. Talk to whoever. Talk to the screen if you want to. Do you see any perpendicular lines, boys and girls? No, we don't. We have these 4 sides, these 4 lines or line segments, but none of them are perpendicular because this one here, when these two guys meet, they're making an acute angle. This one is also an acute angle. When these two line segments are meeting up here, they're making an obtuse angle. So there are parallel lines here, but no perpendicular lines. And if you're thinking, oh my gosh, this is nuts, I'm just going to turn off the video and tell my mom and dad I did it and hope for the best, don't turn off the video. Please don't turn off the video. All right, hang in there. It will make sense. You just need to practice it, right? Look, these are parallel right here, parallel, great, but no perpendicular, because if you take a look up at this trapezoid, we make those nice corners, right? All right, let's take a look at this here, all right? Squares are great because squares pretty much do everything. We have, let me, good color, let's go red, okay? I use these for our parallel lines, but if you look, if I look at this one, I look at this one right here, these are perpendicular because when they meet each other, they make that right angle. Look, when they meet here, it's going to look crazy after a while. That's perpendicular. And if I look here, that's perpendicular. And this is also perpendicular. That's where we're getting, if you remember that definition of squares, that's where we're getting those 4 right angles. Okay, you cannot make a trapezoid of 4 right angles because if you do, you're going to make a square or a rectangle, right? You change it. Okay, all right. Let's look at this one. So let's get some labels here so we can talk about this. So let's call this T, and this is M, and this is M here, and then Y, right? Okay, cool. So if I said TO, and I'm going to line segment TO, so this is the one that I'm right here. You could have said OT if you wanted to, okay? Is perpendicular. I'm going to use that little symbol there, all right? It is perpendicular, not parallel, to OM right here, okay? OM. Because when they intersect, they're making that right angle, all right? Oh, simple, right here, done, okay? So now I have MY, okay? I can look at this one here, MY, line segment MY is perpendicular to, okay, take a look at that right there, OM. That makes a right angle. Check this out. Look, O shows up here, shows up here. M shows up here, M shows up here. Because M, in this case, is right there where that angle is. O, right there where that angle is. Okay, and I could say MY is perpendicular to TY, and that makes a right angle. And then right here. So we have these perpendicular lines that are intersecting, but when they do, they make a right angle. Okay, they're not intersecting and making an acute or an obtuse angle. Like what could happen? All right, here we go. Rectangles. We're looking at the same deal, guys. All right, so if I label this one here X, Y, Z, and then P, whatever. Okay, I could say XP is parallel to YZ, just looking at it how we did yesterday, awesome, parallel. But if I wanted to focus on today, I could say XP is perpendicular to PZ, because when they meet each other, they're making that right angle. Okay, makes sense? Okay, cool. All right, so if I take a look at this, this is just kind of a random mix of things. And there's one thing that I'm neglected to add into this sheet, and I'm just thinking about it now, but I'm just going to kind of keep going with it. I don't want to give you the impression that only quadrilaterals can have perpendicular lines. So I'm gonna kind of skip past this here real quick and bring this up. So you're going to have to deal with some of my really terrible freehand drawing right now. So later on this week, you guys are going to be talking about triangles, right? Perfect, right? So I don't want to steal anybody's thunder, but since I get to teach first, I'm going to. So just act surprised when you see this. Tri means three, tricycle, three wheels, triceratops, three horns. So when you look at triangles, triangles can never have parallel sides, ever, because they're going to be touching in one way or another as it is already. But they can have perpendicular sides. So for example, this one here, this one I kind of freehand drew, looked like these are all acute, okay? You can draw triangles all sorts of crazy ways. You can draw one that's like this really wide open, crazy looking triangle. That's what I'm going to call it now because I don't want to give away somebody else's lesson with a big fat obtuse angle there. And these tiny little acute ones right here, that's an official math word to call it a big fat obtuse. But what I want to show you is you can draw a triangle where it has a perpendicular set of lines like that, right? So if I call this one A, B, C, you can see that line AB is perpendicular to BC. Okay, so that makes a nice, neat perpendicular line intersection right there because it's making that right angle. Okay, I wanted to show you that. So coming back up to here, if you have this printed out, this would be great. I mean, this is something that unfortunately it's impossible to do remotely. If we had this in class, we could do that. But if I said, all right, if we were to circle the ones that have perpendicular intersections, which ones would I circle? Okay, I could circle immediately. I could circle all the squares. Okay, it's kind of like a search and find. I could also immediately circle the rectangles, right? I know I'm not going to get all of them. I know some of you who are watching the video are probably going to be like, oh, he missed one. Yeah, I know I missed one. I'm old and tired. Leave me alone. Okay, but then here's another one up here. Got it. But do you see any trapezoids? Four sides, parallel, at least one set of parallel, right? Look, this one has perpendicular right here. This one's perpendicular. This one also has a perpendicular. This triangle here has a perpendicular intersection right here. Okay. So we can see it like that. This trapezoid up here has a perpendicular intersection. Circles are great, but they don't fit anything, what we're talking about. No angles there. No perpendiculars on this one, right? This is not, look at that triangle. Does that have any perpendiculars? No, doesn't. Okay. So we can start looking at these shapes in many different ways. All right. That's it for this activity. When you guys get to activity 3, take a look at that, read the instructions on that one. If you need any help, let us know. Thank you very much. Bye.